Today is July 14th, 2015. You're not going to read this in any astronomy magazine or astronomy textbook or astrophysics textbook or any book on stellar structure or interiors or how a star evolves into what human beings call a planet, because it's just beyond them completely. So in order to help my readers out a little bit better, here I have the reasoning for the non-existence of young stellar cores. There is reasoning behind a lot of this theory. Young stars don't have cores. They form cores as they evolve, cool, and die, and the material collects in the central regions of the star. And the evidence for there not being a core is fairly obvious once you learn what to look for. According to this theory, obviously, by definition, it's too young to have formed a core. Really hot stars, they haven't had enough time to have formed a core. They're too young. A core takes billions of years to form. Young hot stars like the Sun and Pollux and Bellatrix, they're too young, they're too big, they're too hot. The material has to cool down considerably to be able to clump together. Which is strange because they say, well, the core can't form, or no, you can't have chemical reactions in the Sun because it's too hot, yet there are chemical reactions in the Sun. But it's full of contradictions. Just don't worry about what they say about there being a core there, because there is none. Now, per stellar metamorphosis, this is a population of one star. Obviously, it's very different than what establishment physics says a population of one star is. A pop 1 star is plasmatic, it's luminous. Its main mode of heat release is in plasma recombination, meaning when the plasma combines with other plasma, it is exothermic. It releases very, very large amounts of heat. That's why stars shine and are so hot. The pop 2 star is gaseous and full of supercritical matter, and a lot of the chemical reactions on there dominate. Not electrochemical like in pop 1 stars, but just plain chemical. There can be some more electrochemical reactions in there, but they're more in the interior. They're not outwards oriented in terms of plasma. And you have population 3 stars. Those are liquid and solid material, and they can be life hosting. Pop 4 stars are solid, differentiated, and they don't have a global magnetic field. Sometimes they might have atmospheres, but usually they don't have global magnetic fields, because as you'll see in the next reasoning, that they need to have a dynamo circling a central region. Another reason for there being no core is that it has a very weak, it has a magnetic field global, but it doesn't dominate the other sunspot regions where the magnetic field is a lot stronger. Okay? If there was a core, there would be no magnetic fields that just pop up on the surface. It would completely dominate all the others, and it would keep them coherent. That's a new understanding, but I'll have to work more on that. But as core formation begins and the material falls to the internal regions and clumps together via electroplating and that kind of stuff, I still have a lot to work on with that concerning Markov convection and the ionization potential of the materials, which is why they're differentiated in certain amounts. But as the core begins forming, magnetic fields of the star become less and less willy-nilly. They're not on their own anymore because that core is formed there. And then the dynamo effect can take place as the material falls inwards and the central regions thicken up, which means it gives the magnetic field something to attach to, so to speak. Now, we all know that iron in the previous video has what's called permeability, meaning if you place it into a magnetic field, let's just say there was air there, and then you place the iron there, it will increase the strength of the magnetic field considerably. That means the more iron that collects in the center, the stronger that global magnetic field will become, and it will start dominating the sunspots, okay? And when it starts dominating the sunspots eventually go away. It flares violently because the star doesn't like to have its magnetic fields controlled by a central core. And then eventually the star forms one single powerful global magnetic field, which means all brown dwarfs have very strong global magnetic fields and basically no more spots, no more sunspots, if you will. But as they evolve, they keep some of that material in the outside regions. You know, if there's a lot of, I could say probably iron or different kinds of elements up there that are still swimming around, they can keep kind of like some type of large storms in there. I guess they would be more like the great red spot. I don't know. I have to do much more work with that. And then you have population 3 stars, which would be like gray and blue dwarfs, where the magnetic field starts shrinking because the interior regions are cooling. And then you have further cooling like the Earth, but it still keeps its global magnetic field. And then eventually all the material solidifies in the center, the magnetic field dissipates, and then it continues wandering the galaxy, having other younger host stars rip away the atmosphere because it has no magnetic field protecting it, killing all life, irradiating the entire surface, making it inhospitable in every single way. Like there's no way life is going to be able to survive on something like that unless you like maybe dig a giant tunnel and live underneath the surface or whatever. But there's that. Basically what you can think about is if a core existed, then there would be a global magnetic field. And as well, we know there isn't a global magnetic field because the sunspots are dominating. And if you put iron in the center, that has a very high permeability. Let's write that out. And it will magnify greatly the strength of any type of magnetic field that happens to be in the vicinity. So basically that sums that talk up. It's a few thoughts that I've been having over the last couple years now. Goodness. If anybody has any questions or comments, please leave them below. Do not hesitate.